Hey, chemistry, it's Thursday, April 16th. I'd like for you to turn to 422. We're going to do molality. Would someone please read the definition of molality? Yes, I would be glad to. Okay, thank you. Molality is the concentration of a solution expressed in moles of solute per kilogram of what? Solvent. Okay, let's just compare the two. Molarity, capital M, is moles per liter. This is solute. This is solvent. No. Solution that includes the solute. It isn't just the water. It's the water and the salt. It's the solution. And liters is the volume. So it's moles of solute per liter of solution. Little m, molality, little m molality is equal to moles of solute not per liters of solution, but per kilogram of solvent. Now it's the water, if that's your solvent. Okay, so let's go ahead and keep that up there in the corner, and we'll do our work over here. And let's highlight the equation. There is the equation. Here's the equation for molarity, and they're both ways to express concentration of solutions, things that dissolve. Okay, so let's go over and do a problem, and then we'll go back and look at the pictures. Sample problem D, a solution was prepared by dissolving 17.1 grams of table sugar. Of table sugar, which is C12H22O11, called sucrose. Can you say sucrose? Okay, in 125 grams of water. So the mass of the sugar and the mass of the water. This is the solute. This is the solvent. Do we want solute in solvent? We do. So the mass of the water is 125 grams. Question, is that the right unit? Or do we want kilograms? We want kilograms. Now, first of all, when we go about dissolving things together and use molality as our solvent, the reason is because molality doesn't change with temperature, but molarity does change with temperature. So molality is a nice unit of concentration to utilize. The reason it doesn't change with temperature is because a certain mass of solvent is still a certain mass of solvent when it's warm. But how big it is, the volume of it does change. When it gets hotter, it expands. Cooler, it contracts. But mass doesn't change whenever the temperature changes. So this formula is still good with any temperature. This formula, it changes because that molarity changes. Okay, so with that said, let me ask, how many factors have to be measured with a balance? Grams? The solute has to be measured, and the solvent has to be measured with a balance. And I'll demonstrate that when we get done. Okay, so they want to know the molality. Molality is moles per kilogram. Now, what are moles? Isn't that the mass that they give me over the molar mass? Yeah, so how could you express that formula? You could express it as molality is mass over its molar mass of sugar. Add that up. 12 times 12 plus 22 times 1 plus 11 times 16. Say molar mass. And I'm going to look down here and I'm going to find out. Oh, no. Let's see. Right down here, it says it adds up to 342. Molar mass is 342 grams per mole. Okay. And you put that over the kilograms of solvent. 0.125 grams. 1,000 grams of water is called 1 kilo of grams of water. Grams of water cancel, and we take 125 divided by 1,000, and we get 0.125 kilograms. How many bunny hops? 1, 2, 3. That's dividing by 1,000. And so we're going to put 0.125 kilograms. And so when we cancel the grams, we're going to get moles per kilogram as our answer. Anyway, let's go ahead and do the division. 17.1 17.1 divided by 342, further divided by 0.125. 0.4. If you look on the bottom of 423, 0.4 molar, not molar, 0.4 mole. Can you say that? Mole? Sugar solution. C12H22O11, box around it, and you're done. Next page, let's do another problem. The solution of iodine in carbon tetrachloride. So now iodine is the solute. Carbon tetrachloride is the solvent. You don't know what that is, but the formula for it is CCl4. But we got iodine going into carbon tetrachloride. How much iodine must be added, grams, to prepare a 0.48 molal solution? Molality is moles per kilogram, moles of solute per kilogram of solvent. Molality is the mass they give me, in this case unknown, divided by the molar mass, divided by kilograms of solvent. So the molality is 0.48. Mass is what I'm looking for. We'll call it X, because you guys like X's. The molar mass of the solute iodine, I2. Let's see, it's 127 times 2. That would be like 254. And then the kilograms, let's see what it says. How much carbon tetrachloride? 100 grams, 3 bunny hops to the left, 0.100 or 0.1, same thing. So what are we going to do? We're going to cross multiply. Here's my equation right there. We're going to cross multiply like this. Boom. There's an invisible 1 there. Boom. And we're going to get 0.48 times 1/10 is equal to x over 254 times 1. Now what are we going to do? We're going to cross multiply again. There's an invisible 1. And we're going to get x equals that times 0.1 times 254. And when you do that, you're going to get 12.2. It's grams of iodine. The box around it, and you're done. Pretty easy, capizi. Now go back and look at how we mix that. If you take a look on page 422, we mix it by measuring out in a beaker for this particular thing, 12.2 grams of iodine. We just simply put the beaker on here, and we press the tare button, zero it out, and then we put 12.2 grams of iodine in there. We set it aside, and then we measure out 100 grams of carbon tetrachloride for this particular problem. So we set this on here, and we press tare, and then we pour the carbon tetrachloride in there until it says 100 grams. It says 100 grams. Then we take this, and we take this, and we pour them together. So we got to weigh this solute. We got to weigh this solvent. We pour them together, and then we stir it up, and away we go. We're done. So a little different than using a volumetric flask like you did on page 419 to get molarity. See you.